Next, we'll examine how the two-point form of the Arrhenius equation can help us find our activation energy. Or, if we know all of the other components, we can solve for what we don't know. Consider the reaction between nitrogen dioxide and carbon monoxide. NO2 plus CO yields NO plus CO2. The rate constant at 701 K is measured as 2.57 inverse molar inverse seconds, and that at 895 K is measured at 567 per molar second. Find the activation energy for the reaction in kilojoules per mole. So we see that T1 is 701 K, K1 is 2.57, T2 is 895 K, K2 is 567, and we're told to find activation energy. And of course, R is just the gas law constant in energy units. So we can plug everything in. 5.67 over 2.57 equals, or ln of 5.67 over 2.57 equals EA over R times 1 over 701 minus 1 over 895. So we get the activation energy is equal to 5.40 times K over 3.09 times 10 to the minus 4 times R. If we plug the R in, we get the activation energy is equal to 1.45 times 10 to the 5th joules per mole. And that's because we're going to convert, we put in the R as the energy units, and we can cancel Kelvin, and we're left with joules per mole. And so that gives us 1.45 times 10 to the 5th joules per mole. So that rounds to 1.5 if we have 2 sig figs times 10 to the second kilojoules per mole. For practice 15.8 says, use the results from example 15.8 and the given rate constant of the reaction at either of the two temperatures to predict the rate constant for this reaction at 525 Kelvin. So we found the activation energy. We know one point we need to solve for K2 at 525 Kelvin. So here we can write that the ln of K2 over K1, this again is the two-point form of the Arrhenius equation, is equal to EA over R in energy units times 1 over T1 minus 1 over T2. And so now we can see that the ln of K2 is 2.57 inverse molar inverse second, and that's equal to 1.45 times 10 to the 5th joules per mole divided by 8.314 joules per mole Kelvin. That's our R in energy units, times 1 over 701 Kelvin minus 1 over 525 Kelvin. So we can simplify ln of K2 over 2.57 molar to the minus 1, second to the minus 1, is equal to negative 8.30405. We can use our logarithmic rules to simplify the left side a bit, saying that ln of K2 minus ln of 2.57 is equal to negative 3405. So rearranging the ln of K2 is equal to negative 8.3405 plus ln of 2.57. So the ln of K2 is equal to 7.3966. So in order to get rid of the ln, because we have a variable here, we take e to the ln of K2 equals e to the 7.3966, and we get K2 is equal to e to the negative, and that was negative 7.3966, e to the negative 7.3966. So K2 is equal to 6.13 times 10 to the minus 4, and the units are molar to the minus 1, second to the minus 1.